All right, everybody, if y'all kind of mosey on back to your seats, we're going to get started here in just a second. Wrap up your transactions with Gary back there. Get yourself something fed. Gary, I'm going to come back and get something in a second. Yep, get everybody settled in here. Can't start because the speaker's over there doing something. Thank you very much, Howard. I hope everybody enjoys coming to the meetings. I hope we got some good things happening, and we're going to try to keep things going here. Don't forget about Dr. Joe's open house on Sunday, 1 to 5. Please go to the website. Our open houses are very strong. There's a lot of people been attending them. So if you know, the activity of the traffic going in and out has been real good at the different open houses on Sunday. So thank y'all for going and participating. And the hosts go to a lot of trouble to try to have it. Least we can do is try to go and enjoy their hospitality as well. So, ready? I am not going to sing a song up there. Tom, you ready? I know you've been ready. Okay. So I'm going to go ahead and while he's working on that, I'm going to introduce you. I'm not sure the camera is lined up correctly. Tom, you may need to swivel that camera a little bit. Not sure it's focused on the. Turn it back toward me just a little. Turn a little bit more. There you go. That should be right. Okay. Our speaker tonight is Tom Gordon. Tom actually was a crucial part of the SCR 2023 convention. He's going to bring you tonight a clinic, and I think he's put a lot of stuff together. He's got a few things to pass around. He's an electronic guru guy. Guru, nerd, whatever you want to call it, nerd. But he knows his stuff, and he's going to share with y'all some real exciting stuff tonight. And but I wanted to say thank you for willing to put on the clinic tonight. So I think they're about ready to go here. So Tom, if you're ready, we're ready for you, sir. Thank you very much.
All right, thanks, Walt. I'm going to be passing some stuff around, and I know for the people that are not here, it would be a little tough to see. So I'm going to tell you what I'm going to pass around. I'm just going to pass this box around. This is a completed panel that I didn't use. I got a couple of them. I'll be doing a demonstration of how I replaced this panel. This is one reason I made my panels real small like this with the plug on the back. And I'll tell you why this one's replaced. This is a really dumb move on my part. This is the panels that this is how they start. This is what you can get from Amazon. Super cheap. I think it cost $0.25, if that much. This is one of them painted. I'm hoping the people online can see this. No, they can't. And, you know, graphics before glue. So, and I got some wire and a toggle switch in here. I'm going to pass all this around. Wanted to get that started and tell you what was in there. And I'll be telling you about all these things. And I'll start over here. Anyway, I've done a number of these presentations on panels. And, you know, I've made some interesting control panels for the layout. And they work. Unfortunately, they haven't been very flexible. And so I decided to revisit what I've been doing with Trackside panels and making the word life could be a little bit better. First off, always the goal is have them cheap, and you get parts easy and difficult to destroy. Spill proof maybe is one thing, but the other panels that I've done in the past, which that's one of them right there. Really nice, look great, it's covered with plexiglass. You know, how nice. However, if I wanted to change something, that thing was covered in plexiglass. I'd have to re-drill a whole bunch of stuff and make a big mess, and it just wasn't necessarily a good idea. Let me see if I can do previous on this. There we go. And I also wanted to make it to where if I did replace these guys, it was easy to reconnect to the layout. As you notice with the boxes going around, the panel that I replaced has a plug on the back. It was, I'll tell you how that was done in a little bit. I won't tell you how to make the plugs. That's for another time. The plexiglass panels are great. If things are not going to change, go for it. As most people will realize with layouts, you build something, you go, I could do this better. Gee, I need an industry over here. I'm going to put a turnout here. Yeah, not worth it. So I decided to change the way I did panels. So I scatter a bunch of these little beasties around the layout like this. You can see this is a part of Cedartown. There's 4 little panels here. I think there's one to the right. And you go around that island, there are a couple of panels. Around the other side, there are a couple of panels. There's a Rot Mart, which is the picture on the right, has a whole bunch of small panels, and above it are the turnouts. Now, granted, you have to figure out which turnouts go to that panel, but I tried to make them as obvious as possible. And after operating the layout a little bit, you realize, oh yeah, that's for here, that's for here. Life is good, not a problem. And if I decide I don't like a panel or I want to change one, I can rip it out and put another one in with only like a few days work. And that's clock time waiting for paint to dry. So to make these little beasties, you just need little basic woodworking tools, screwdriver, paintbrush, sandpaper, drill, a computer with a color printer, soldering iron. Yeah, if you have any electrical stuff on it, that's kind of handy. And I use scissors to cut the graphics. And power tools, very simple. A drill with a step drill bit. Now, I was really made aware of step drill bits probably about 4 or 5 years ago. Before that, I had no earthly idea what they were. God, they're great. I can just drill a pilot hole and then make the hole as big as I need it. And that's like a #1 step drill bit. They aren't horribly cheap, but they're like $10. So, and you can get them at Harbor Freight, so you can save some bucks there. So basically, to create the panel, the hardest part is making graphics to where the graphics are going to be good. And I'll show you how they're bad in an example in just a few minutes. You want to create the graphics, use a graphics program, print it out, make sure it fits on the little panel real nice, do a little cut and fit type stuff, and then you print it. Now, I will take that graphics and spray fixative on it. Artists use it for pastels and things. It's great to keep water-based ink from running. Not all printer ink's going to give you a problem with that. I do it out of superstition. I just spray a little. I had some Grumbacher fixative. I'm out of that. I bought some Krylon from Amazon. You spray it on there. It seals it pretty well, and it keeps it to where when you put 4 or 5 coats of nice clear gloss stuff on top of it, it doesn't make the graphics behind it blur. Your mileage may vary. Test it with something you find you may not need that. So don't worry about sealing with the fixative so much until you know it's a problem. You'll paint those panel boards, the little board I showed you earlier, and I have a picture of it in a minute. Paint it, put a number of coats on the top of it, on the side, on the good side that you want people to see. Make it nice and pretty, and I had a nice green, which is good. Home Depot, Lowe's, all those places, just use that paint. That's the best stuff in the world. Trim the graphics to fit the board, and then glue the paper to the board. Again, real simple stuff. Then I got the clear gloss sitting on top of it, and let that dry real well. drill the holes, install the parts, attach the wiring and connector, and then above all, test it before you install it. It's sometimes, especially if, in my case, I run a ground and a 5-volt lead to all the panels. And, if you happen to get some of that reversed, maybe some of your electrical components wouldn't be too happy. So you don't want necessarily to do that. So make sure you do a testing. As for the wiring, which when that thing comes around, when you start doing a wiring, again, I'm going to show this again in a real example. I'm telling you what went through. Have a standard, have something that you use. It's most of my panels are unique for a particular location. I have a color code that I use for the back of the panels. The blue light for Turnout that's operating in hand, it uses a blue wire. It connects to a 5-volt. My 5-volt standard is brown wire, or in the case of the stuff where I get the wire from, it's kind of a purplish brown, but anyway, it's brownish. Good enough. That's 5 volts. We're in good shape on that. But have a wiring standard. I have for 12 volts, I always use well, never mind. I'm going to get into that. That's not even involved with this. Ground is green. So do that with green. So I have a standard, the way that I have it set up. And when I feed the wires to these little panels, I have another standard that I use for punch down blocks. And again, I'm not saying that this is the way you ought to do it, but you want to document these things before you put them out, before you start using them. But also be aware, documenting it like this in this amount of detail that tells you, what color of these are Cat 5 wires. This is orange and white with orange stripe. It has a 160 ohm resistor. The color of the LED is there. All that stuff is all set up. It doesn't work with what the NMRA requires for the AP electrical. They want a diagram. They want a spaghetti bowl. And this is actually usable. So just take that with a grain of salt. If you want to send something in for the AP electrical, don't use this. It's not going to work. But if you want to use it for you to go back and fix it, and believe me, I've had to use these again. It pays off having it very well documented, where the wire comes from, where it goes, and label the wires themselves. Make sure you know what they are. Now, for materials for the boards, other materials, say if you had tools earlier, you want you have that little board, and I'll show you an Amazon thing with a little board in a second. You want to use photo quality print paper if you want it to look really, really cool and nice. If you want to use it weathered, use just plain old paper, the stuff that you use to print off whatever you feel like. The beauty of using plain old paper is it makes the panel look kind of old. If you want the panel to look kind of new, use good photo quality stuff. Again, it doesn't matter. It's just according to what you feel like using at the moment. You have the little craft panels. You have the spray paints that you use. The panel hardware is that I use. I use LEDs, and there's some going around, and I'll show you some pictures of them in a minute. I use toggle switches and buttons. I've used 1/4-inch phone plugs. I have a lock and key thing for track power on the layout that I can, well, I'll tell you about it when I show you the picture in a minute. And spray adhesive. The small panel stock, which is probably the most important item in here, and the only thing is really radically different. These are little 4x4 panels that I found on Amazon. This thing you can get 100 of them for $22. Okay, so you can mess a few up. You can give some to your friends. It doesn't matter. They're really cheap, and they're like 1/16 of an inch, or I think these are 1 millimeter. in thickness, and the electrical parts fit right through them very nicely. These are great, and they have all kinds of different styles on Amazon. You can buy a package of 50 of them, but I figured I'd do 100 because I figured I'd screw a few up, which I have. But and it's also nice because I can use them in other places for other things. Electrical parts that I've used with these, a T1 mount for a T1 LED. LEDs are the, you know, they're the little LEDs, but they're not the surface mount beasties. The T1 LEDs fit in the back of these. I use T1s and I use good ones. I don't use ones from Joe's Junk Box or something like that. I actually order some from like Mouser. Jamico's are pretty good or whatever. You want a consistent color amongst all your panels. So don't get cheap ones, get good ones. Push buttons, I actually have a handout that has all the part numbers and stuff on it. So save the trouble. I have push buttons and toggle switches that I use. The big trick on any of these is making sure that you have a large enough throat on it for the screw thing to fit through the panel. It's very easy to get one with a very the screw part of the toggle switch is very short. It won't fit through the panel, so you want to make sure that everything fits through. So paints, I mentioned earlier, fixative, the color paint that you want to use. I use green for the front, black for the back. A clear paint, I use Krylon, again, available from Amazon or Home Depot. Nice thing with Amazon, I can order four bottles or 4 spray cans of it for a fairly decent price. So that's real nice. And I like to use for the adhesive, the 3M77 spray adhesive. How many have used that 3M stuff? Yeah, you don't want to get it on you. So maybe I ought to add gloves to the list of things you need for parts when you're building these things. Because if that stuff gets on your fur, on the hair, on your arms and stuff, it makes a mess. So just be aware that stuff you want to be careful of. Some notes on some of the electric parts with these. Make sure the throat's big enough. I mentioned that earlier, and good quality. I like to use those little LED mounting tabs. Again, so it'll be this in the handout. I like using those little tabs because it covers up all kinds of sins when you're drilling the holes in the front that kind of messes up the paper. You slip those little tabs in there and all those problems just go away. So that's really kind of nice. Now, sometimes with those little collars, the LED doesn't snap in real nice. So I do not recommend using hot glue to hold the LED in. And the main reason that you don't want to use hot glue is LEDs are heat sensitive. And I ran a very hot glue gun and toasted an LED or two with that. Couldn't figure out why they didn't work. And then it was like, geez, I should have realized. So if you use hot glue, you want to use a very tiny bit. I just use super glue on it now. But be careful when you're using super glue to glue the LED in there. The super glue can go through to your graphics and maybe make them run just a little bit, but generally it's not too much. Again, that's why I have 100 panels. I can try them out. So make sure you give each layer time to dry. You don't want to just quick, keep piling stuff on, paint on another paint, No, let it dry. Let it dry, maybe 4 or 5 hours, maybe overnight, which is good. Have a standard for your plugs and document all your wiring. Now, I will show you again an example. Now I'm going to walk you through actually doing this, giving you kind of an overview of it. This was a panel that I replaced that's going around. Now, you might not see anything wrong with this except that one of the turnouts has both the lights lit. Don't worry about that. But the operator standing above that panel, which is down here, that's what he would see. The only problem is that's what it looks like. Notice the bottom LED is right underneath that push button. So what that ends up doing, see, you can't see that thing lit from here, but you can see it from here. The operator doesn't notice the turnout is not thrown correctly. Now, in reality, the operator should know, but, you know, anyway, I'm the one usually operating it with it, and I kind of mess it up every now and then. So I decided to replace the panel. First thing, I've noticed my panel is labeled, the plug is labeled. That's RK for Rockmart 9/10, turnout 9, turnout 10. That's what this panel controls. The plug has the label on it. The back of the panel has the label on it. If you'll, the one that's going around, you'll notice there's an RK 9/10 on it. I know that I made this for this spot. I can plug it in and life is good, usually. I'll paint the panel replacement squares. I'll paint the back first because it's the least important. You don't have to paint the back, but I just kind of feel it's nice to seal it. I'm a little superstitious about warping. Never had these warped. They're really a plywood, so it shouldn't be that much of a problem, but I do it anyway. And then I put several coats of green over like a couple of days and let it ignite and looking really nice. Now I'll at the same time go create the graphics. I have a standard template I use for the graphics. You can use what you want. It's fairly easy to do. You know, print them out, get a good feel for it. Once you make one, you can just copy and make a whole bunch more of them, make them exactly the same size. And use, trim them with scissors and print, and you're done. Now, again, optional to use a fixative. Not all printers will have ink that runs when you spray Krylon on it. Some do. So just be aware of that. Do a quick test of that to see what works and what doesn't. So once that little panel is dry, once you get that nice green coat or whatever color you want to use, I'd cut out the paper, spray the back with the 77 adhesive. Again, disposable gloves are often a good idea, and then carefully place the paper onto the little piece of wood. And that's probably the most complex piece because sometimes it's easy to get the piece of paper a little bit off and you might end up not looking that good, in which case print another one, grab another panel that you made, try it again. It's not hard. So once you let the adhesive dry, the 3M77 adhesive does require a certain amount of drying time. It's not horrifically long, but you do want it to dry. Start painting it with a nice gloss finish. And I found like 2 or 3 coats work. There's actually one of the Krylons they make for craft stuff is triple thickness or something like that you can spray on there. I've tried that before. It kind of works nice, but it doesn't really matter. Just make sure that each coat dries pretty. And if you like what the finish is, if it's smooth enough for you, move on to the next step, which is drill starter holes. When you use the step drill, I use like a 1/16 bit and drill a hole in the middle of each one of these dots that I created on there. The big dots are for the toggle switches. The small dots are for the LEDs. Then I go through and ream out the holes. Now you can see where the trashy paper pieces on the side wouldn't look good. That's why I use those little trim pieces on there. Because it's kind of hard to get these guys totally trimmed away and nice and neat. So those little LED clips work quite nicely. Put the components in. This is actually the panel that replaced the one that's floating around the room. And you stick them in, you stick the LEDs actually snap into the back of this panel. I still put the super glue on it. I'm just superstitious. And then you're done with the hard part of making it to where what the user sees is right there in front of them. So you can now look at it. You can see on this particular one that this button and this LED are not directly vertical from one another. For wiring parts, I get wiring from several different places. Yeah, and I've done presentations on making those DuPont connectors. I use DuPont connectors everywhere on the layout that I can, especially everywhere there's low voltage, not track voltage, but like 5 volts and 12 volt for buildings and stuff. I use these wires that I get from Pololu Electronics, which should be on here. I better be on here. And of course it's not, but anyway, Polo, P-O, Polo, P-O-L-O, Polo, Pololu, P-O-L-O-L-U. It's an outfit in Denver that makes parts for robotics. You can get these pre-crimped wires from a lot of different operations. And I just have them all the different colors that I use on my panels right there. And I just trim them, strip the ends, and just makes life a lot quicker and makes it a lot less sleep lost on did I really crimp that particular plug right or not. It's done by machine, so makes life a little bit easier. I connect the wires. I have a standard for that. All the LED resistors are external to my panels. I use punch down blocks for all these connections. And if you've ever used a telephone punch down block, there's a neat place right down the middle of it that'll fit a 1/4 watt resistor just perfectly. So for a button, I'll bridge that. And for an LED, I'll put like a 160 ohm resistor or 1,000 ohm resistor in there. And you can just run it down the middle. That's why I have those spreadsheets telling me what needs to be where. I arrange the wires in the socket according to the standard that I've designed, that I came up with, which I showed you earlier. It's nothing complicated, and it's not really absolutely necessary to follow it to the letter every time. There'll be exceptions when you have a custom panel for something. But keep things as close as you can. Notice the back of this panel has that RK9/10 on it. Yeah, that's the new one. The old one had the same thing on it. If one should break, I can swap it out. I'm not gonna, but anyway. So now I tested it on the workbench. I can feed 5 volts to it and test the LEDs, or not 5 volts, 3 volts to it, and test the LEDs and make sure everything works and everything's fine. And here you can notice that right-hand button is not obscuring the LED. So now I'm happy with that particular panel. So I use a couple of different kinds of panels on the layout. This is a track power cutout that I have on the layout that has a key on it that I can start the layout up. I use JMRI. Well, I use CMRI for all my layout control, and JMRI controls the CMRI. I'm not going to get into all that detail works, but basically all the electronics behind the scene, except track power, I can turn on. So I can run turnouts. I can do all kinds of stuff with the layout without ever firing up the track voltage. I have a key that fits into that panel, and it turns it on and powers up all the different boosters on the layout and connects them to the track. But one thing I've done on that, though, is when it's turned off, the relays that power that send the track power to the track ground. So all my rail is grounded when when the track power is off. Anybody see an advantage in that? Yeah, well, it has a lot to do with static electricity, and I have a lot of static electricity, and I found that my engines generally hold their programming a little bit better now. It's still the jury's still out on it, but so far so good. It's really kind of nice. So I turn it off, the relays drop, they drop to ground, and it's signal ground for all the rest of the stuff. So I don't have as much of a static electricity, and I don't have as many of the engines forgetting what they were. Yeah, that can have something to do with it. Yeah, carpet and cold weather. Yeah, yeah, you touch it. The chair I have at my desk tends to, when I roll it back, tends to generate static electricity. So I found that having everything grounded, instead of going through the engine trying to complete a circuit, it just goes straight to ground. And so far it's worked real nice. So, but it required running a little wire around the layout from that panel with the key on it. I do have dispatch control layout, turnouts. I have a few of them. In this particular case, I have a toggle switch with the turnout is in normal or reverse. I have a place for a key to fit in. And behind that is actually a little Arduino that controls everything. You had never noticed I do like Arduinos. I have engine house power. I have a small engine house for a somewhat branch line on the layout. Now, this one I cheated on. I don't have a plug for that. I ran one of the leads to this and one of the leads back, and I just don't worry about it too much. It's but it shows how you can use this for engine house power. You flip the toggle switch on, the LED comes on. It'll let you know that that particular track on the engine house has juice to it. Again, using the same kind of technique, the same kind of method to create the box. I think it needs to go over. Oh, yeah, it needs to go over here. Yeah. And of course, sometimes you want a little bit more than the 4x4. So I created this on 1/16 Masonite. Same kind of concept, same kind of thing. It's not as plug in behind it as an Arduino Mega that controls routing logic and track power and turnout logic behind the scenes. And you don't want to look at the back of that panel. It's not really that neat, but it does work real well. I can punch a button on one of the turnouts, like this particular one right here, and it not only selects it sets the turnouts here, it turns the power on that particular leg. Otherwise, if I push this button right here, it makes them all go straight and kills the power on all those. But that's all in the programming of the Arduino Mega behind the scenes. So that's real nice. But it's way too much for this presentation. I wouldn't mind doing a how to program an Arduino presentation, but I think it'd put all of you totally to sleep. So anyway, that's really about it. I wanted to show you just an easy way of doing panels, an easy, cheap way of doing panels that are really flexible. And I'll entertain any questions. I have a handout up here. Yeah, sure. Grinding my track. Yeah. What I did is the track power and that little of that controller that has the little toggle switch on it. When you turn the key, it sends 12 volts around the layout. I have 3 different 10 amp boosters on the layout, and it connects the boosters using double pole, double throw to the to the track. When the power is off on those, both sides of that are both connected to ground, the logic ground of the layout, which goes through a computer power supply to the ground in the outlet next to the house. So it totally grounds them. Now, granted, a computer power supply is not a straight shot to that. It goes through some resistors, but it effectively grounds all the rails around the entire layout. And, you know, the whole idea is just to cut down on issues associated with static electricity. Sir. Yes. Yes. It kicks it over, and if it's active, it's a double pole, double throw. It's if active, both rails are then connected to the booster. And if it's not active, it's connected, both rails are connected to ground, and they're shorted. So that way, knock on wood, it should cut back on the on some of the static issues that you have with controllers. And it's only because I bought that stupid chair for my desk that has plastic wheels on it that I really should have something that's grounded better. But I figure, it was easy enough to do this. And so far, it seems to work rather nicely. So, anything else? Okay. Well, thank you very much.
Thank you, Tom. Very good presentation. Appreciate it. Hey, wanted to thank everybody for coming out tonight. Little housekeeping duties. If you got any trash around, if you'll please pick up any of your trash and dispose of it. I think he has some handouts up here. You're welcome to come get them. Check the website. Come to get handouts. Check the website. Like I said, we got an open house at Dr. Joe Jr.'s house this weekend on Sunday. And please be respectful of a host when you show up, and he'll be glad to share with you anything you'd like to learn while you're on there visiting. So everybody, we'll see you hopefully at some of the events. Monorail Run 101, new member reception, and the meeting next month. Y'all have a safe trip home. Hopefully you get home before the Braves cut loose here in a little while. Have a safe night.